So today I am here to solve some of the remaining questions which has been asked by you from exercise 4.2 regarding determinants. Okay, so let us proceed. So when this question was asked that use properties of determinant to prove, this is our question number 6, to prove that determinant of 0 a minus b and minus a 0 and minus c and b c and 0 it is equal to 0. I have to prove this one. Clear? So let us start. So I will start from LHS directly. Now I am just simply applying a property row 1 is replaced by row 1 plus row 2. Let us see what I get. Row 1 plus row 2, that will be minus a, this will be a itself, and this will be minus b plus c. Minus b plus c. Now this one will be minus a itself, 0 and minus c. This one is b, c and 0. Clear? Now to make another 0, what I will do, I will just replace column 1 by column 1 plus column 2, right? So let us see what I will get. Here column 1 will be replaced by column 1 plus column 2. Then this will be 0, column 1 plus column 2, this is a, this is minus b plus c, and this one will be minus a plus 0, which is also minus a, this one is again 0, this is minus c, this is b, this is c, and this one is 0, right? So here you see this one is 0 a minus b plus c, minus a 0 and minus c, b, c and 0. Now you directly expand this, right? So if I expand, I am just using this part of the board, please see. If I expand, then 0 has nothing to do, this one will be plus and this one will be minus here, so minus b plus c. Now a, you remove the row and column containing a, right? So what will be left here? Minus a minus c, and here it will be left is b and 0. Then again minus b plus c will be left, right? This will be plus, and the things which will be left here is minus a 0 and it will be b and c. Clear? So if I multiply, here you can see a will be multiplied by, this will be minus a into 0 and minus minus it will be plus bc. So first term will be abc, and minus b plus c will be multiplied by minus ac. Okay, so let us proceed. Minus b plus c, it will be multiplied by minus a into c, and a will be multiplied by minus bc, sorry, plus bc, right? So what I will have now is, it is equal to a multiplied by minus bc and plus minus b plus c will be multiplied by, look at this, what was that? Clearly, let me see. Look at this. What I will do is, I will just expand. This one was 0 a minus b plus c, minus a 0 and minus c, b, c and 0, right? So let me write that once again for you. That is equal to 0, and this one will be a, and this will be minus b plus c, and again this one was minus a, this one was 0 and this one was minus c, and this one is b, c, b plus c, sorry, c and 0. Okay, so now what I will have, just expand. Here 0 has nothing to do, a will be multiplied, you remove the row and column containing a, that will be minus a minus c, and here it will be b plus c and 0. Then plus minus b plus c will remain here, and what is left? Minus a 0, and this one will be b plus c and it will be c. Clear? So now what is left? Let us see. A into this one is 0. Now minus minus it will be plus, so bc plus c square. Now here minus b plus c, and it will be left, it is minus ac. Is that clear? So if I do this, let me use this part of the board. This will be equal to here a into b into c plus ac square, and this one is minus a into b into c and plus c minus ac, it will be minus ac square. So you can see all the terms are getting cancelled. This is cancelled with this and this is cancelled with this, and at last I am getting the value to be 0. So this is how we solve this question. In fact, even if you do not use any property, directly it will be solved easily, but since the question has asked to solve this by using the properties, you have to use this method, right? So now let us proceed to the next question which has been asked by you. Okay, this is our question number 10. First bit, I have to prove that x plus 4, then 2x, here 2x, then 2x, here 2x, here it is x plus 4, here 2x, and here 2x, and here x plus 4. It is equal to, I have to prove that this one is equal to 5x plus 4 multiplied by 4 minus x whole square. Please keep the book with you. This is question number 10, PTI, page 120. Okay, so I have to prove this one. Clear? Now let me begin. To begin with, what I will do first, I will replace r1 by r1 minus r2 so as to create number of zeros, and r2 I will replace by r2 minus r3. Okay, let me see what I get. This is r1 minus r2, this is 4 minus x here, then r1 minus r2, this is x minus 4 here, and r1 minus r2, it will be 0 here. Similarly, r2 minus r3, it will become 0 here, x plus 4 minus 2x, so again it will be 4 minus x, and 2x minus x minus 4, which is also x minus 4. This is 2x, this is 2x, and this is x plus 4, right? Now what I do, I take x minus 4 common from row 1 as well as from row 2, so I can write it as square, because x minus 4 I have taken from row 1 common, and x minus 4 also I have taken from row 2 common. Now x minus 4 if I take, it will be minus 1 left here, this is 1, this is again 0, and this one is x minus 4 I have taken, this is will be 0, and this will be minus 1, and this will be 1, and x this one will be 2x, and again it is 2x, and it is x plus 4. Okay, right? So what I do is, let us save this one first. Now look at minus 1 plus 1 will give you 0, so I can try it out, and this is also 2x and 2x. If I subtract them, I can get another 0, right? So I can create 0 in either way. Either I will add column 1 and column 2 and subtract column 1. Now the thing is, if I replace column 1 by column 1 plus column 2 plus column 3, look at this, right? So column 1 to be replaced by column 1 plus column 2 plus column 3. Here it will be 0, and here it will be 0, and here it will be, that will be 5x plus 4. Okay, let me try it out. Or row 1, I can also replace row 1 by row 1 plus row 2 plus row 3, but it will be better to replace column 1 by column 1 plus column 2 plus column 3. Before that, let me tell, this will be 2x and x plus 4, no change, minus 1 1 0 0 minus 1 and 1, right? So let me write it once again, x minus 4 whole square minus 1 1 0 0 minus 1, and this one will be 1, and here it is 2x and x plus 4. Let me match it. Okay, look at this. This is minus 1 1 0 0 minus 1 1 2x and x plus 4, right? Okay, now what I do is column 1 I'll replace by column 1 plus column 2 plus column 3, right? So this will be x minus 4 whole square. Now this one will be 0, column 1 plus column 2 plus column 3, this one is also 0, and this one will be left as 5x plus 4. This one is 1, this one is 0, this one is minus 1, this is 1, and this is 2x, and this is x plus 4. Clear? Now what I do is expand along column number 1. So x minus 4 whole square, then 5x plus 4 will remain, and the things which is left after remaining 5x plus 4, it will be 1 0 minus 1 and 1. What I do here is expand along column 1, right? So it will be x minus 4 whole square and 5x plus 4, and if I multiply this one will be 1. So in the question it has been asked to prove 4 minus x whole square. In place of x minus 4 whole square, you can write 4 minus x whole square, because they are the same thing. So x minus 4 whole square multiplied by 5x plus 4, or 4 minus x whole square multiplied by 5x plus 4, right? So now what I will do, we will proceed to the next question. Okay, our next question is, this is question number 12. I have to prove 1x square 1 and x, this is x square and 1, and I have to prove this is 1 minus x cube whole square, right? So let me show it. Okay, you also have the book with you, so that it will be easy for you to grasp the things, right? Now 1 plus, so first thing which I am going to do is column 1 I am replacing by column 1. All right, let me change the trick. What I'll do is row 1 I'll replace by row 1 minus, plus row 2 plus row 3, right? I repeat. All right, it has been erased. So in solution, this is our question number 12. I will have, first the thing is 1x square, and this is x square, this is 1, and this is x square and 1. So what I will do, I will replace row 1 as row 1 plus row 2 plus row 3. What I will have, this will be 1 plus x square, the same thing 1 plus x square, this one will also become 1 plus x square. Now this one is x square, this one is 1, this is x, this is x, this is x square, and this is 1. Next what I will do, 1 plus x square, I will take is common. If I take common, this is 1 x square x, this one is 1 x square, and this is 1 x and 1. Is that clear? So let me save this one. Please have a look at once again. This will be this one. Now what I will do, I will just 1 x square and x is there, I will try to make as many zeros as possible. So let us move to the next page. So my thing was 1 plus x square, and the remaining thing inside this, it was 1 1 and 1. This is x square, this is 1, this is x, this is x, this is x square, and this is 1. So what I'll have is, I can do in either way. Either I will replace column 1 row 1 minus row 2 and also row 1 minus row 3 to make it 0. So what I'll do is, let me take it in this manner. Column 1 will be replaced by column 1 minus column 2, and column 2 will be replaced by column 2 minus column 3. Is that clear? Right? So let me rewrite this one once again. This one was 1 plus x square, and the remaining thing is 1 1 1 and x square, 1 x and x square and 1, right? So what I'll do, I'll replace column 1 as column 1 minus column 2, and column 2 I'll replace by column 2 minus column 3. So what is left? 1 plus x square. Now column 1 minus column 2, it will become 0. This is x square minus 1, and this is x minus x square. This one is also 0. This is 1 minus x, and this is x square minus 1. This is 1 x and 1. So what I will have now, what you take x minus 1 common from column 1, also x minus 1 common from column 2. So what I will have, 1 plus x square, and this is 1 minus x. I have taken common both from column 1 and column 2, so it should be square. Now column 1 I have taken 1 minus x common, so it will be minus 1 plus x. Clear? Next, I have taken also here 1 minus x common, so it will be only x left here. Similarly 0, I have taken 1 minus x common, so it will be 1 left here. And here what I will have, this is x square minus 1, I have taken 1 minus x common, so it will be minus 1 plus x. Now what is left? 1 x and 1. Clear? Now even if I take this one, so 0 0 1, so only 1 will be left, and minus 1 plus x, 1 x and minus 1 plus x. Clear? So let me save this one. Now erase. What I'll have, this is 1 plus x square, then it will be 1 minus x whole square. Then let us see this one, right? What is left now? Minus 1 plus x, 1, and x minus 1 plus x. So it will be minus 1 plus x, 1 x and minus 1 plus x. Okay, let me see it once again to confirm. See it. Minus 1 plus x, 1 x and minus 1 plus x. Clear? Now what is left now? 1 plus x square multiplied by 1 minus x whole square. Then it will be inside the bracket, it will be 1 plus x whole square minus this one again will be x square, not x square, x into 1, it will be x only. Okay, so what will be left? 1 plus x square whole into 1 minus x whole square. Now what will have? This one will be 1 plus x square, 1 plus 2x plus x square minus x. Clear? Now what I will have? This one is 1 plus x square multiplied by 1 minus x whole square, and again it is 1 plus x square. Now what I will have? 1 plus x square multiplied by 1 minus x, its whole square, right? So if I take, you can see easily this is nothing but 1 minus x cube formula. So in the next, what I will have, let me save this page. In the next page I will write it as, so it was 1 plus x square whole into 1 minus x, its whole square, hence it will be equal to 1 minus x cube and its whole square. This is equal to RHS and the things are proved. So this completes your chapter exercise 4.2. So your homework is remaining questions of exercise 4.2, remaining questions. So these three questions have been asked. I ask you to solve the remaining questions. If you are facing problem in any of the questions, then you send your query. I will be solving it and sending it to you. Is it clear? Okay. Thank you very much. That's all for today's class.